Good day everyone, Mr. Cargill here with our next AutoCAD video, and for this video we are going to look at how we go about constructing a parabola when we are given the ratio of eccentricity. Alright, and I did a video on parabola already, but that was how we go about constructing a parabola when you are given the axial length and the span. Now, as for the ratio of eccentricity, the term eccentricity means how much something deviates from being a circle. Alright, so an ellipse, you could use the ratio of eccentricity to construct an ellipse or a parabola or a hyperbola because they all deviate from being a circle. Alright, for a parabola, the ratio of eccentricity is always going to be unity. So it says right here, for a parabola, the locus of a point which moves so that the distance from a fixed point called the focus, then in this case, in this drawing here, this is the focus right here, point F. Alright, and from a straight line called the directrix are always equal. So this is the focus here, and this is the directrix right here. Alright, so focus and directrix. Alright, so here it says that the ratio of eccentricity for a parabola is always going to be unity, or 1 to 1, or 1 over 1, meaning that if I draw a line from here, from F to any point on the parabola, so this point here, alright, and then if I draw a line that is here from here that is perpendicular to the directrix here, then this line is going to be equal to that line. So that means that the ratio of eccentricity is always going to be 1. Alright, so if I should draw a line from F here to a point on the parabola, say this point here, and then if I should draw a line that from here that is perpendicular to the directrix, this line here is going to be equal to that line there at all times. So that's what that means. Now we are going to start constructing our parabola, and for the parabola that we're going to be constructing, when you're given a parabola or a hyperbola or an ellipse to construct, when you're given the ratio of eccentricity, you'll be given two things. You'll be given the ratio of eccentricity, and you'll be given the distance from the focus to the directrix. Alright, so in this case, on the focus here to the directrix over here. Alright, now what I want us to know is that for a parabola, as I said before, the ratio of eccentricity is always going to be equal to 1, or unity. So that means that if you're given a drawing and the drawing says complete this drawing and the ratio of eccentricity is 3 over 3, 4 over 4, 2 over 2, something like that, that is going to be what you're going to be drawing is going to be a parabola, because the ratio of eccentricity is always equal to 1. And for an ellipse, the ratio of eccentricity is always going to be less than 1. So the ratio of eccentricity for an ellipse is going to be something like 2 over 3 or something like that. So for an ellipse, the ratio of eccentricity of an ellipse, the denominator is always going to be bigger. Alright, and then for a hyperbola, the ratio of eccentricity is always going to be greater than 1. Alright, so for example, this is a hyperbola here. So the ratio of eccentricity is going to be greater than 1, so it's going to be something like 3 over 2. So that means that when you're given the ratio of eccentricity, if the numerator is smaller, then the curve that you're going to be drawing is going to be a parabola. Sorry, a hyperbola. Alright, so equal to 1 is a parabola, less than 1 ellipse, greater than 1 hyperbola. Alright, so we're going to start by drawing our parabola here. And it says that we're given the distance from A to F. So AF from the focus to the directrix here is 60 millimeters, and VF equal 30. And V is halfway between A and F. Alright, and this is 30, from B to F is 30. Alright, so we're going to go into AutoCAD and start constructing our parabola. Now this is one that I've constructed earlier. Alright, so we're going to start with the directrix, and the directrix is just a vertical line. Alright, no specific length. So let me turn on ortho since I'm drawing a vertical line. I'm going to draw a line, let's say from here. Alright, let me start over a little bit further. Let me draw a line from here. Alright, and then now I have that's my directrix. This line here is my directrix. Then I'm going to draw the center line here, I'm going to draw that center line. All right, so let me just use a different color. Let me use white for that. No, if I'm going to draw the center line, so ensure that in AutoCAD you have midpoint turned on. Ensure you have midpoint turned on, and then from the midpoint here I'm going to draw a line. All right, this line has no specific length. All right, so this line has no specific length. So let me just draw it out to somewhere like here. All right, now the next thing that I'm going to do is I'm going to find the focus. So the focus is point F there. All right, and in the instructions it has said that AF is 60. All right, so we have point A, and from A to F is 60. So let's find the focus over here. So first of all, let me label this here. Let me label that A. So let me just copy this A from here. Bring this over here. Turn off ortho. All right, so now we need to find the focus. I know the focus is 60 millimeters away, so we can do two things. We can do a number of things, including we could offset this line over here by 60, or we could just copy this line from the center here and bring it over by 60. Just type 60, enter, and that is our focus. So our focus would be this point right here. Now let me give the focus a different color because I want to distinguish between the focus and the directrix. So now the focus is point F right here. So let me just copy this F and label my focus over here. All right, so this is my focus. Now I have this is my directrix and this is my focus. So now I was given the ratio of eccentricity, and the ratio of eccentricity is 3/3 for this parabola. All right, and as I said before, for the parabola the ratio of eccentricity is always going to be 1, and if you divide 3 by 3 you get 1. All right, so I'm going to add the 3 plus the 3 that is the numerator plus the 3 that is the denominator. I'm going to add 2 of them and I'm going to get 6. And what I'm going to do with that 6 is this. I'm going to divide AF into 6 equal parts. All right, so I'm going to divide AF into 6 equal parts. If I click on the line, it highlights the entire line, and I don't want that to divide AF. Let me just trim this line here and redraw it. I can just trim that line there. And then let me just draw a line from A to F. Like that. I'm going to turn on ortho to ensure that my line is indeed a horizontal line. Here we go. Alright, so now I can click on that line and as it just highlights from A to F. And I'm going to divide from A to F into 6 equal parts. Alright, so I'm going to type divide. It says select object. I want to divide the line, so I'm going to click on divide. It says enter the number of segments. I'm going to type 6 since I want to divide it into 6 parts, and I press enter. Now as you can see, my line is divided into 6 parts. All right, now if we type that you want to divide the line into 6 and then you click enter, if nothing happens, if these markers don't come up right here, just type DDP, click on DDP type, and then you can select any one of these markers that you want to use to mark a line and what size you want them to be. So I normally use this one, but you can use any one of them. All right, good. Now we have AF, and that is divided into 6 equal parts. Now in the document it had said that from V to F is 30 millimeters, right? So we know we have found point V, so let's label point V. So from V to F is 30. If this entire line is 60 and from V to F is 30, that means that V would be in the center between A and F. All right, so let me copy F and then just change it to, so that means that it would be, V would be right here, right, halfway between A and F. So let me label this V. All right, good. So this point here is our point V. No, we have an important point as well. All right. In this drawing, it's called point C, but I'm going to call it, sorry, it's called point P, but let me just call it point C for the purpose of explaining it right here. Now, for this drawing, I'm going to find the point C. And for C, for any drawing that you're doing, whether it be a parabola or a hyperbola or an ellipse that you're doing using the ratio of eccentricity, VF, all right, VF or FV is always going to be equal to VC. So we know that VF is, in this case, is 30. So I'm going to draw a line from V upwards here, and I'm going to make this line 30 millimeters. So 30 and press enter. All right, so VF is equal to VC. So let me just label this C. Let me label this point C. All right, so that's my point C. Now I'm going to need this diagonal line here that goes from A through C. All right. Now for a parabola, that line is always going to be 45 degrees. All right, but for a hyperbola or an ellipse, that line, the angle of that line is always going to change depending on the ratio of eccentricity. And the reason for it always being 45 degrees for a parabola is that AV is always going to be equal to VC right here. So if I draw a line from A through C, I'm basically completing a right angle triangle. So this line here is always going to be 45 degrees. All right, this line here is always going to be 45 degrees because AV is equal to VC. All right, and that means that if I was to draw a line from C to the directrix over here like this, I would be completing a square. All right, and so that means that if I draw a line from A to C, then it is going to be 45 degrees. All right, so now, knowing that our line is 45 degrees from A through C, we can set that angle here. So let me turn on polar tracking here. Click on the drop down button and ensure that you have this turned on: 45, 90, 135, and so on. Now I'm going to draw this line from A, and I'm going to just extend it out here, no specific length. This like that should be good. All right, and that green, see that green line that extends out, that tells me that the angle is 45, and you can see right there where it says the angle is 45 degrees. So let me just click there. Let me change this line. Let me give it a different color. Let me just make it a white line. All right, good. No, so we have that. All right, so the next thing we're going to do is this, and this, it's important to like zoom in and check. And when I zoom in and check this, I see that it doesn't meet that point. And if it's not meeting at that point and my angle is set at 45 degrees, that means that something must have gone wrong down here. And if there's nothing wrong down there, then I just have to redraw that line or check VC and ensure that it is indeed 45 degrees. Sorry, indeed 30. All right, so that looks like it's drawn from the right point. All right, so let me just double check this to see if it is indeed 30, and then I can check to see if I can also double check to see if the angle changed from 45 as I clicked. All right, so that is 30, so that's no problem. So let me just redraw this line. Let me also check to ensure that from A to F, from A to V is also 30 as well. Let me just double check that. Let me double check that from B to A. All right, so that's the problem. That wasn't completely 30 degrees, 30 millimeters, sorry. That was 29.8613. So let me check this over here and see what this is here. The same 29. So that means that this wasn't offset exactly by 60, and that's what caused the problem. So let me just do this again. Let me just offset this. So you wouldn't need to do this again. I'm just doing this because this time let me turn ortho on, and then that should be good. So you wouldn't have to do this over. I'm just doing this because that line got messed up. I'm going to offset that by 60. Now F would be that point there. Sorry about that. All right, so if I offset this line here by 60, all right, so that's my point F. Good, lovely. All right, so let me just change back F and make it cyan, different color. All right, nice. So that means I have to redraw this line here now. Let me just delete this line, and also let me delete these points. Just delete all of those points. All right, so let me redraw this line from F, and this little piece that is off right here, this is why the measurement was off. So when you see things like that, you can always zoom in and check and just troubleshoot and try to figure out what the problem is. All right, so that's good. So now this is indeed going to be exactly 60 degrees. All right. I'm not going to edit out that part of the video simply because it's kind of good so that you can understand, like, when you come into troubles when you're doing drawing, or you can go about troubleshooting to try and figure out what the problem is. All right, so I'm going to divide this line again. So let me just type divide, click on the line, enter 6, and then those are my 6 division points right there. So that's good. So now from V, I'm going to draw this line 30, and then I'm going to draw my line from A through C. All right, so let me draw my line from A. Let me just ensure that it's actually coming from A and not just a random point. Good. Let me turn off ortho and turn on polar tracking. So I'm going to be drawing a 45-degree line, and I'm going to draw that line like that, and now my line should be going through C. Perfect. Right, so my line goes through C, so I know that it is exactly 45 degrees. Now I'm going to divide this center line into a number of parts. The amount of parts that you divide it into does not matter. The distance between the lines that I used to divide it doesn't matter. The lines don't even have to be equal distance apart. The reason for that is this: for a parabola or a hyperbola, all right, these points will be moving away from each other constantly. All right, so a parabola could continue on into infinity. This point here could continue on all the way out, and this point here could continue all the way out in this direction, and these 2 points will never meet because the ratio of eccentricity is unity, so it's always moving away. These points are always moving away from each other. If it was an ellipse, then it would go like that and come back around. But being a hyperbola, it can go on into infinity. All right, so we're not going to draw like the entire hyperbola, because as I said, it can go on forever. We're just drawing a portion of the hyperbola. All right, like that point right there. Now I'm going to divide the center line into a number of parts. I'm going to make my division points be about 20 millimeters apart. As I said, it doesn't have to be exactly 20. You can use 10, 15, 5, anything you want to use. You will end up with the same thing. But if you use a small number, you'll end up with a lot of points. If you use a larger number, your points will be far apart, but you will still get the same parabola. All right, so what I'm going to do is I'm going to offset the focus by 20, since I want to divide the line into 20. Since I want to divide the line, and the measurement I'm using is 20 millimeters between each point. Let me not copy, let me offset, and I'm going to offset by 20. So to can click on offset and click 20 and press enter. Then I'm going to click on the line, since this is what I want to offset. It says I'm supposed to click where I want to offset it from. I'm going to offset it from here, and I'm going to bring it over this side. All right, I'm going to offset it from here, bring it over that side by 20. All right, and I brought it over this side also. What I'm going to do is I'm going to extend these lines, and the reason for extending these lines is I need them to pass this 45-degree line here, and when I start bringing the lines over here, you can see that they might be shorter than this, so I want to extend it past that point right there. Let me just extend, I don't need to extend this one. Let me extend this one since this is the one I'm going to be offsetting. All right, so let me offset it like this. I'm going to offset it. Let me turn on ortho because I want it to be a completely vertical line. I'm going to offset it like that up there, and then I'm going to offset it down here as well. And then I'm just going to copy that line or offset it all the way across. Let me change these lines to white lines because I don't want them to get mixed up with the focus. No, I'm going to keep on offsetting this line, all right, into a number of parts. Let me do like 3 more points. All right, as I said before, the number of lines that you have don't really matter because the parabola can go on into infinity. I'm going to select offset. The offset distance is already set at 20, so I don't have to worry about that. I'm going to offset it from here. Sorry, select offset, select the line, click on 20, select this line that I want to offset, and then bring it over here. I'm going to like 1 more point here, so that's good. Now I'm going to number these lines. So this line here is 1. F, which is the focus, is also our next point, so F and 2 would be the same point. I'm just going to leave it as F, and then this will be 3, 4, 5, and 6. Alright, so let me label these. We'll just copy this. I'm going to turn off object snap because I don't want this to be snapping to the lines. Alright. Good. So now let me just change these values and give them their correct name. So this would be 1 here. If I said, as I said before, F and 2 are the same points. This over here would be 3. And then we have 4, 5, and 6. Alright, so 1, 2, 3, 4, 5, and 6. Now, we're going to plot some points, and to plot those points, we're going to use these circles to help us. Now, if this was manual drawing, meaning if I was doing this on paper with like pencil and a compass and stuff like that, I would have my compass point here at 1, and I would open my compass to where this vertical line from 1 meets this diagonal line here, this 45-degree line. So my compass point here at 1, open it to where this line here meets the diagonal line at this point. I would have this radius from 1 to that point there. I would put my compass point at F. Alright, I'll put my compass point at F. Then I would cut line 1 both above and below. Alright, and I would do that for all the other points. So now let me draw one circle to show you what I mean. Alright, so I'm going to draw this circle here from 1. Let me turn on back object snap. I'm going to draw the circle here. Ensure that you're drawing it from the actual center. And I'm going to bring it to this intersection here, to that point there. And to get that point, ensure that you have intersection and apparent intersection turned on. Apparent intersection and intersection turned on in object snap. So then now, I'm going to move this circle from 1 and bring it to F. Reason for moving the circle. As I said, if it was manual drawing, I would put my compass point here and open it to that point. I would have that radius on my compass. Then I would put my compass point at F, and then I would cut this line. So again, compass point here, open it to here, put my compass point at F, and then cut that line. Alright, and then I will get that point and then that point down here. And then we're going to do that for all the other circles. Now we're going to draw a circle from F as well, because F and would be 0.2, and we're going to bring that right there to where this line from F meets this diagonal line. And we don't need to move that circle because it's already drawn from F. Alright, so that circle is alright, we don't need to move that circle. So now for this circle here, we're going to draw that circle from 3 to where the line from 3 meets the diagonal line right there. Alright, then I'm going to click on that line and I'm going to move that line from 3 to F. Alright, I'm going to click on a circle again. I'm going to go to point 4, click right there, bring my circle up here where this line from 4 meets the diagonal line, and then I'm going to move that circle from 4 to F. All right, good. Then I'm going to select the next circle from 5 and 5 here. I'm going to move that circle up here to where 5 meets the diagonal line. Then I'm going to click on the circle. I'm going to select move, and I'm going to move the circle from 5 and bring it to F. Then I'm going to select a circle again, come to 6, draw my circle from 6 to where this diagonal line meets this vertical line from 6, so right there. I'm going to click on that circle, and I'm going to select the move tool, and I'm going to move it from 6 here and move it to the center, which is that point right there. So now I have all my points. I just need to start plotting them. Now point V, as you can see over here, point V, which stands for vertex. All right, so V means vertex, which is like if the tip of the ellipse, basically, not the ellipse, sorry, the tip of the parabola, basically. All right, so we have all the points for a parabola. All right, I have all the points for a parabola. Good. So V is like the tip of the parabola. Good. All right, so now we're going to start plotting our points, but we're not going to start from V, because if we start from V, we might end up getting something looking like a point, and I don't want a point. We want a smooth curve like this right here. So to get that, we're actually going to start from the end. All right, and we're going to select, for that we're going to select line or spline, S-P-L-I-N-E. So just type that, select it right here. Now we're going to use a different color for that. Let me use lime green. All right, so here, this is the large circle, the largest circle here. So this is circle 6. All right, circle 6 is the largest circle, right? As you can see, this is line 6 and this is circle 6. So circle 6 meets line 6 right here at this point. So this is the point that we want. The next largest circle, as you can see, circle 5, because this is the second circle, second largest circle, and this is line 5 here. Let me just turn off ortho. So circle 5 meets line 5 right here. So that's our point. And then you will see the trend. Circle 4 meets line 4 there. Circle 3 meets line 3 there. Circle 2, which comes from the focus, meets circle 2 there, meets line 2 there. Then line 1 meets circle 1 here. And our next point is the vertex here. Let me just zoom in and ensure I'm clicking the right point. There we go. Then for our next point, circle 1 cuts line 1 down here. Circle 2 here cuts line 2 here. Line 2 is the same line from F. Circle 3, which is that one, cuts line 3 here. Circle 4. All right, so this is the fourth. This is circle 4 because it's the third largest circle, and it cuts line 4 right here. Circle 5, which is the second largest circle, cuts line 5 right here. Circle 6 cuts line 6 right here. All right, then just press spacebar, and there you have your parabola. All right, so that's your parabola given the ratio of eccentricity. All right, so I hope you found this video helpful. If you did find it helpful, you can always drop a like and subscribe so that you can get more content when I upload. And also you can leave a comment and let me know if you found the video helpful, and if there's any other videos that you would like me to do, any other topics that you would like me to do videos on. All right, so thanks for watching, and do have yourselves a wonderful day.